Hello, everyone, from wherever you may be. I'm Kevin Clark, Content Director for Power Engineering, and I'm delighted to speak with Sean Sexstone, who is GE-Hitachi's Executive Vice President of Advanced Nuclear. He is responsible for leading the company's advanced nuclear business, and he's going to talk a little bit with us today about the company's BWRX-300 small modular reactor. So, Sean, what is this reactor, and why should people be excited about it?
Yeah, well, Kevin, first, thanks for having me on. Excited to be here with you today. Look, at GE, just in general, we're very dedicated to solving the energy trilemma of security, affordability, sustainability, and nuclear is the perfect mix for that. Our BWRX-300, which I'm happy to talk about, I'll give a high-level overview, and then we can ask whatever questions we need. But the BWRX-300 is boiling water reactor, X for 10th generation and 300 for 300 megawatts. I think it's important to point out the 10th generation. So we've been doing this for more than 60 plus years. We were the first to put a commercial reactor in the US and Canada, and the evolution continues, right? So this design, this 300 megawatt design, is based off of our ESBWR that was certified with the NRC previously, and that was a 1,500 megawatt, so much bigger plant. And one of the challenges that you have when you think about how do you make these small is not just shrinking a reactor. You can't just shrink a 1,500 megawatt reactor because the costs and the scale don't come with it. So you have to drive innovations. And that's what we've been able to do. We have a very large design to cost team focused on constructability, focused on design, really getting cost out of the plant. One of those innovations are called an integral isolation valve that we have patented. I won't go into a lot of detail, but basically eliminates the loss of coolant accident scenario, or if, let's say, you lose power off site, these valves close, keep all of the coolant in the reactor. And we're able to just eliminate a lot of equipment, a lot of concrete, steel. Roughly 90% of the concrete and steel from our ESBWR has been eliminated. So think about that on a scale perspective. Really able to simplify, but also have a much safer reactor as well. And so you think about the size of that, right? That's I was at the Charlotte FC game with my son the other night, and we were talking about this because I tend to talk about nuclear a lot with him. But it will fit on a normal football pitch, right? So think about in meters or yards, roughly the same, 130 yards or meters by 65, and that's from control building to all the way through the turbine building. So not baby reactors, but much smaller and much easier scaled across the energy landscape. And the other important point about it, if you think about simplification and trying to have nothing new, I like to call it the SMR simply made reactor, because really we're doing nothing new. We're using the same components that we have in all of our boiling water reactors around the globe. 95% of it has been done. Maybe these are a little smaller in scale, but very proven, and that's a big part of what we're excited about. Oh, and I'll mention, I'm sorry, I'll mention because I don't want to forget this. A big part of the advantage that we have is the fuel, right? We're using the same fuel that we're using in most of our boiling water reactors today. So that's a key part of just as you think about growing at scale, not having to worry about licensing new fuel or where is your supply chain coming from. That's a big part of new technology that we eliminate that risk.
Thank you for adding that as well. I was going to mention that because the overall theme is it sounds like not that there isn't any innovation going on here, but how much of that in terms of the existing concepts and attributes will make it easier for GE Hitachi relative to other companies in this so-called race to deployment we have it here in this decade?
Yeah, I think that the whole supply chain and making sure this is just a simpler version of what we have out there today, right? We've been building steam dryers and reactor internals for decades. right? So, and then that on top of using the same exact fuel, no tweaks, nothing that needs to be changed through licensing space, I think allows us to get to market a lot faster. And I think that's what you're seeing out there in the marketplace is when customers look at this and what does success look like, it's for them, it's about predictable outcome, right? And how do you get there quickly and know that thing's going to work for the next 60 or 100 years?
You all have had some very interesting partnerships and agreements that have been signed surrounding the BWRX-300. One of them, the TVA and Ontario Power Generation and Synthos Green Energy agreed to somewhat of a technical collaboration aimed at investing in key components like the reactor pressure vessel. Can you talk a little bit about this and what the goal of this is?
Yeah, it's really interesting partnership, and I commend the leaderships all the way up to the CEO, obviously, in each one of those companies. They're real, I would say, anchors or rocks for us, right? In Canada, in the U.S., and Eastern Europe, and the collaboration's about a couple things. One, I think about what we're doing over the next year and a half surrounding the execution of the OPG contract, which I'll talk about maybe in a minute, but we have to drive our standard design through a process because we don't want that to change, right? And so it's important that it's not just GE Hitachi coming up with the design and then you go to another customer and they say, well, I want this building to be black instead of blue, because that drives different costs and non-standardization. So the big first part is all three of those we call it the collaborators, but the customers ultimately are involved in our design center working group and helping design what that really looks like, what a standard should be. And the goal is then once that standard's set, it doesn't change. And then we can work on driving down the cost curve as we deploy multiple reactors. That's the first piece. The second piece is financial in nature. I mean, this is a $400+ million effort over the next year and a half, and they've agreed to pay for a good chunk of that. And that private-to-private partnership is it's really visionary, I think, but from the leaders in those companies. They know that they need nuclear. They know it's going to be a staple of their generation, and they've picked the X300 and are willing to really invest, hard dollars into making sure this is successful.
Speaking of OPG, you just mentioned it a little bit, but there's a signed contract, not an MOU, but a signed contract to deploy an X300 at OPG's Darlington new nuclear project site. Talk a little bit about that project, if you would, and what is the timeline that we're looking at right now for what could be the first grid-scale SMR in North America?
Yeah. And that's what we're very proud of, being the first commercial contract in North America. And you got to hand it to OPG, real leaders in this space right now. A great customer, a great partner. They have really taken the bull by the horn. This was a year and a half process of evaluation. First of all, going through all the different technologies in SMR and advanced reactor space. We're honored that they selected us, and the partnership has been great. The other partners we have there, I'd be remiss if I didn't mention, is Aecon and Aecon's Nuclear Group, which is the largest nuclear constructor in Canada, and then SNC-Lavalin, well-known global company, very big focus in Canada as well as our architect engineer. So we're all working together in an integrated project delivery model where we're all incentivized to make this work and to drive out costs and execute on time and on budget with a high quality manner. The license to construct, which is the first process, and you think about building a reactor, they license to construct, and then you get a license to operate. The license to construct, that application was submitted at the end of last year. They expect to receive approval at the end of 24. So when that happens, that's when real hard construction starts. Of course, right now we're getting the site ready. We're like we talked about with the design, finalizing that design, both in the standard design and the site specific. And also we're ordering, big equipment, long lead engineered equipment that is important to maintain the schedule. with the goal of being operational at the end of 28 or early 29. So really excited, a lot of focus on that project specifically, and obviously on our standard design, but OPG leading the way has just been fantastic for us.
Sean, in general, what do you see as the main hurdles for licensing and deployment in terms of meeting commercialization goals and timelines here through the decade?
Yeah, it's a good question. I think about this in two ways. I don't see risk or challenges in technology space or even getting the right components at the time we need. And really not even in licensing space. I think sure there'll be challenges when there's a number of applications in certain regions, but there's a lot of harmonization going on between the US NRC and the CNSC in Canada and many other regulators around the world in Poland and the UK and Czech. And so I think that harmonization will help that licensing piece, and we'll get there. I view my challenge or our challenge as a business right now is two things. One, of focus, right? We have to get this first one or two right. That has to be the main focus. It's easy to get distracted, right? As you could imagine, as we look to decarbonize all of these energy sectors, there's a lot of interest and there's a lot of customers coming to us. So we have to be smart about how we engage and really focus on what we have at hand. Can't go chase ball here and there. And that's, I think for us, that's in the GE DNA all the way up to our CEO. So that really helps kind of level set us and make sure that's a big focus for us. And then I guess the other challenge that I see as we grow and we get more and more potential contracts and we're going to execute is that supply chain piece, right? And how do you scale at this level? I think we're comfortable in the first, so many. I won't comment on how many, but in OPG going first, they're setting up a really solid Canadian supply chain. But if you think about GE in general, I mean, our energy equipment powers a third of the world, right? That's a massive scale in every country you could imagine, and that really helps us, gives us confidence to systematically figure out how we're going to grow in different regions, how we're going to engage, how we're going to make sure this is standardized, and get those key supplier partnerships and really execution partnerships as well. So those would be my two main ones. I don't think it's a technology thing. I don't think it's licensing. It's how do you stay focused and how do you deliver at scale?
That is Sean Sexstone, GE-Hitachi's Executive Vice President of Advanced Nuclear. Thank you for your time, Sean.
Thank you, Kevin.